Hi everyone, welcome to today's video where we're going to dive into the basics of parabolas. If you've ever looked closely at the shape of a satellite dish, the arc of a water fountain, or even a curved bridge, then you've seen a real-world example of a parabola. Today, we'll explore what parabolas are, their key features, and where we commonly see them. So what exactly is a parabola? A parabola is a U-shaped curve that appears in a type of graph called a quadratic function. Quadratic functions are functions where the highest power of the variable, usually x, is squared. They look something like this. This is the standard form of the quadratic equation, where a, b, and c are numbers. When we graph a quadratic equation, it creates a U-shaped curve we call a parabola. Depending on the a value in our equation, the parabola can open up like this or down like this. Here are some of the key features in a parabola. The first is the vertex, which is affected by the a and the ax squared plus bx plus c. The vertex is the highest or the lowest point on the parabola, depending whether it opens upwards or downwards. If the a is positive, then it will open down upwards, and if the a is negative, it will open downwards like this. Parabolas are symmetric, meaning they mirror themselves along a line called the axis of symmetry. The axis of symmetry always passes through the vertex and divides the parabola into two equal parts. It's given by the formula x equals negative b on 2a, which you would substitute using your a and b values from the equation given. The y-intercept. This is where the parabola crosses the y-axis at this point. In our equation, ax squared plus bx plus c, the constant c represents the y-intercept. Parabolas aren't just something you find in maths, they're also in the world around us. For example, the path of any object thrown in the air, like a basketball, follows a parabolic curve. Satellite dishes and telescopes use parabolic shapes to focus signals and light to a single point. Even the design of some bridges incorporate parabolic shapes to help with structural strength. Why study parabolas? Understanding parabolas helps us solve real-life problems. In physics, engineering, and even economics, parabolas help us understand patterns, model behavior, and predict outcomes. So that's a quick introduction to parabolas. Now you know the basic structure of a parabola, its key features, and where to spot them in everyday life. In the next video, we'll start graphing parabolas and exploring how changing the values in an equation affects the shape and position of the curve. Thanks for watching, and I'll see you next time.